Hi guys, welcome to lecture number 6 of PyTorch. So guys, today we'll be talking about classification as promised. So guys, see, classification is one of those problems where you would see neural nets being more utilized than regression, because guys, see, the thing is that a lot of times linear patterns are captured in regression, and you would often find that ML models are relatively simple to train, relatively simple to code, relatively simple to manage, relatively simple to scale in terms of infrastructure and deployment. So that is why often you will find out whenever you have linear patterns in your data set, or you have a trend line kind of a situation, then you often go with the normal ML based models, right? But guys, classification is a different ball game. Here you need to classify, let's say, between two labels, 0 and y. So 0 and 1. So in my NLP series I have discussed about classification a lot, so you can have a look at that. But that's part one of the ball game. Part two is that we'll be using PyTorch in order to explain everything what's happening. So guys, let's just go out there. So guys, simply we are just importing torch and the neural network module of it. That's simple. Now guys, last time I showed you, right, how you can go to this runtime place and configure your runtime. So just if you click on runtime, change your runtime type, you can just go on T4 GPU and choose it. Okay, so guys, first of all we are just printing the device, so it would print out CUDA. So guys, CUDA is a, I would say, a layer of programming or an application that has been designed by NVIDIA that helps developers compute and carry out multiple calculations on GPU. So guys, I've been stating this fact again and again in this course that also in your news and all you would have heard a lot about GPU, since guys the main idea is that this is the compute engine that helps in training neural networks. Also at inference time also you use GPU only. So you need to understand why do we need why do we need GPU. The main reason is, guys, it helps you fasten up your calculations and helps you perform calculations almost 10 to 100x than a CPU. So guys, see, we are just printing whatever GPU name we have and what is the GPU memory that's allocated. That's okay, you can skip this part. Now guys, the main thing that you need to move is, in order to create a dummy data set, see guys, we are creating a simple data set in which we have two features for x, okay, and y is your classification. So it's 0 or 1. So the size of x is 200 comma 2. That means you have 200 rows and two columns. So your vector is going to look something like this. If you would just construct it, you would have some number here, some number here, and this depth would be about 200. Okay, and actually this is not depth, this is height, and this is your depth, this is extensively 2. Okay, so 200 rows and two features. You're just defining it. It's just random v stack and h stack. So v stack just stacks vertically. So here we have 100 points and 100 points, so we are vertically stacking them in order to create 200 points. That all is okay, because mostly whenever you will be working in industry, you would have proper data sets and everything. Okay, now guys, next step is to just move our stuff to GPU. So see guys, this is the power of using PyTorch, right? See, simply you are able to move to two device. If you are doing this command, right, dot to device, you'll be able to move your x and y to GPU, and essentially all your further calculations are also in GPU. So it makes more sense to have them into GPU. And I've been talking a lot about tensors, right? So we need tensors. They are the building block of PyTorch. They help you speeden up calculations on GPU. They help you compute complex calculations simply via just high level wrapper of PyTorch. So you can just quickly get this stuff done. And we are being talking a lot about float, right? Because we need our weights in float, and also that is why I'm using float tensor. Okay, I think we are good over here. Nothing very difficult. Now guys, in the last class I explained you that why do we need data loader, right? I explained you that how it is memory efficient, right? How it helps in shuffling points, how it helps in parallelly loading and automatically batching. Is the main reason why we use data loader is that it helps you create batches very simply. Okay, so you have a data set and you can't load the entire data set at once in the neural net, because the thing is that this would speed up your training process, but this would also it would be very heavy on your memory as well. So you would need to choose, usually we do it in batches. So what does doing it in batches mean? That is, you split the data set into multiple batches, and then you pass that multiple batch in that mini batch into the neural net, and at the end you compute the average loss. So guys, that's how it works. In this way, the training time goes up, but also it's a little relaxed on your resources. So that is why we use data loader. Guys, see, the main point of using data loader is that it helps you create batches automatically. You don't have to track indexes and all. Even in one of the projects that I'm doing is we need to just track indexing, right? Because my data frame is of pandas data structure, and I'm not using PyTorch there. So see, tense, if had I been using PyTorch, I would have simply used data loader. It would have taken care of everything. And just see guys how simple it is to create a data loader class. I mean, not a class, a data loader instance is just simple to create, right? All you need is to uh, combine your x and y tensor. You need to define the batch size and shuffle. So guys, see, shuffle is equal to true because it helps you randomly shuffle data sets, and which is very important since it helps you prevent memorization and everything. Because if you would keep sending maybe some stuff again and again and again, so the neural net will not understand it, rather memorize it. So all these things are there. Now guys, see, you can just print out how the data loader is going to look like. All that is been done by this code, very simple code, nothing so great. You can just copy and paste it, you would be able to understand it. And guys, this code you would be using again and again in your life if you would be doing any sort of stuff with PyTorch. So let's just understand. So guys, in batch 1 I have defined a batch size of 32. So as I said that you have two features. So in first batch you will have 32 over here and 2 over here. Okay, that means you have two features, 2 in width and 32 in height. Then guys, you are having 32. Then CUDA, this is the amount of GPU memory that would be used. So guys, we have a 16 GB GPU. So we are just using 0.01 MB, which is fine. So we have first three features. See guys, as I said, right? So it's just printing the first three features, and it has two columns. Okay, and these are the first three y tensors. Okay, that means our binary classes 0 and 1. So guys, total number of batches are 7. So why guys it is 7? Because like we have 200 samples, our batch size is 32. So if you would do 32 into 6, you would probably understand it is 192. Okay, so that means 192 records would get properly classified into 6 of the batches. Then you would have a remainder of 8. So last batch size is 8. Guys, all you need to do is same. Okay, the same you did in we have discussed all this previously as well. So you need to understand, next thing is that you need to define the neural network. So guys, see, we have been defining neural network in the entire course. This is a simple neural network. You have 2, then you have 16, then you have 8, then you have 2. Only thing you need to remember over here is that what will exactly happen in this neural net is that, let me just show you where would that part come. See here, we have defined two neurons. So how would the model work is that it would assign probabilities to both of those two neurons, and the higher probability would be the class that would get assigned. So guys, we are defining a loss function. Usually we define cross entropy for our classification based problems. You can read about it a bit. And guys, we are using Adam optimizer. Last time also I showed you the main objective of neural network is to just find optimal values of weight, and for that we use back propagation. And guys, the main thing about back propagation is that we need to do some sort of weight update with this health equation. W new is equal to W old minus learning rate of change of loss function with respect to W old. And guys, all this thing is covered in the neural net section, but yeah, just try to understand that optimizer helps us get this stuff done quickly. Then guys, what is the model information? We are just printing the model architecture, nothing else guys. Basically this is our simple model architecture, just given I'm explaining you how to just create model architectures and everything in PyTorch in the most simplest manner. And then guys, I have been doing this in the entire course, right? The training code. See guys, in length you might find it confusing, but the thing is you would be using this code over and over again, so it would become very easy. The main thing is that you'll be training for 100 epochs, and in every epoch you will have mini batch training, so the data won't be fed at once, it would be fed in mini batches of 32. So if you would just try to understand what are we doing guys, see, in simple, what we are doing, we are first of all resetting our gradient. then we are doing forward pass, okay, then we are computing the loss, then we are doing back propagation, and then we are updating the weights. Okay, this is what a neural network does, right? I've been talking it about in every lecture, and then we are just like computing the average loss. So if you would just like get this stuff done, like if you would open it, like this is very basic because we are just training for 100 epochs, and you're able to see how there is some stochastic variation, but your loss is getting reduced, and like obviously this is just for theoretical part of things, and you're getting accuracy of 100%. So obviously guys, the model is the neural net is trying to memorize the data. You never have 100% accuracy, but I just wanted to give you a flavor of how do you move from regression to classification. It's very simple. This is the main part that you need to understand, that whichever class would have the higher probability, because we'll be using a combination of softmax and negative log likelihood, it would uh, pick up that class. That's it guys. And slowly guys, we'll cover every aspect of PyTorch, but this is the main background of PyTorch that you need to understand, that how do you create a data loader, how do you define an architecture, and how do you write your training loop. Because guys, if you are not able to understand these things, then it would become difficult to scale it further. And also guys, in the end, it is a good practice to just clean up your CUDA space. So you could just run this command. It's going to help you just clean up your memory and save on resources. So on that note, I would like to end, and guys, please subscribe. A lot of more interesting content is planned up. And if you have any doubts in terms of anything, you can directly reach out to me on LinkedIn or Instagram. Have a great day guys.